Another famous example is to consider the settling out conditions of a compressor suction system. Suppose we are having this centrifugal compressor. The centrifugal compressors are subject to surge scenarios. So if the compressor faces a great discharge pressure drop, or if some valves on the discharge were closed by mistake, this can get the compressor to the surge region, which can be very damaging to the compressor. That's why it's common to add anti-surge system where the anti-surge valve shall open, permitting the recycle of the flow to the suction system. The point of recycle is usually at the inlet of the compressor suction scrubber. This way we can avoid that the compressor enters the surge region. I have talked about compressor surge scenario in deep and the methods to protect it in the compressor section in my hydraulics 4-in-1 course. You can check the course if you like in the bonus section. The issue here is that the compressed gas is recycled from the discharge line to the suction line. This introduces high pressure and high temperature due to compression to the suction system. That's why we are required here to consider the design pressure of the suction system to withstand the worst case scenario, which is this scenario. The highest pressure, in this case, shall be when the outlet discharge valve is closed. The inlet valve to the suction scrubber is closed and the compressor is recycling the gas from the suction to the discharge. This can happen in an extremist way when the anti-surge or recycle valve fails in the open position. Commonly, its fail-safe position is in open position. So when the anti-surge valve fails in the open position, this means that the control valve won't exhibit the required pressure drop, which is the difference between the suction and discharge pressures. Also during instrument air failure, inlet and outlet shutdown valves shall fail in the closed position as well. So the recycle will have a pressure very close to the discharge pressure. Here, the pressure of the system shall reach an intermediate pressure between the suction and discharge. This is called the settling out pressure. The settling out pressure is usually calculated from the fraction of volumes for both the suction and discharge systems relative to the suction and discharge pressures. So, if the volume of suction system is greater than the volume of the discharge system, which is mostly the case by the way, the settling out pressure will be closer to the suction system than the discharge system. But still, it can be much higher, especially if the discharge pressure is much greater than the suction pressure. So here, the suction scrubber and piping up to the inlet suction scrubber should all consider the settling out pressure as their design pressure.